College Algebra, Module 5, Topic 5.2, Quadratic Equations and Problem Solving. A quadratic equation in one variable is any equation that can be put into the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. Some examples are x squared plus 2x plus 5 equals 0, x times x minus 3 equals 5, x minus 4 times x plus 6 equals 3, and 4x squared plus 7x minus 9 equals 4. Objective 1 is solving quadratic equations by factoring. We're going to start with the zero factor property that says if a times b equals 0, then either a is equal to 0, b is equal to 0, or both. This method of solving quadratic equations requires you to be able to factor. Recall, to factor means to write as a product. So if we said to factor the number 8, that means write it as a product, so we could call that 4 times 2, or we could call it 2 times 2 times 2. So if we tried to factor x squared minus 5x, we could write that as x times x minus 5. So let's go back and review some steps for factoring. The first thing to consider, is there a greatest common factor? That is the largest number that will divide evenly into every term. If so, factor it out to the front. For example, to factor 6x plus 9, the GCF of 6x and 9 is 3. So what we do is we write each of those terms as a product of 3. So 6x would be 3 times 2x, 9 would be 3 times 3. Because we can look and see that each of those terms have a factor of 3, we pull the 3 out, which leaves us with 2x plus 3. Second example, factor 2x squared plus 6x minus 10. Is there a number that will divide evenly into each of the 3 terms? Well, 2x squared, 6x, and 10 all have a factor of 2. So the greatest common factor is 2. So if we pull the 2 out front, 2 times what would give us 2x squared? X squared. 2 times what would give us 6x? That would be 3x. And 2 times what would give us negative 10? That would be negative 5. So this is what we're talking about when we say factor out a greatest common factor. The next step is, can you factor by the backwards FOIL method? Well, this is what we use when we're factoring a trinomial, 3 terms, of the form x squared in the first term, x in the middle term, and no x or a number term in the last term. If you'll remember, FOIL is a method that we use to multiply 2 binomials. Well, factoring by the backwards FOIL means the first 2 factors have to multiply to give us x squared. The outers and the inners are going to combine to give us the middle term, and the last 2 numbers will combine to give us a 3. So there's no greatest common factor in x squared minus 4x plus 3. So we're going to set up our 2 sets of parentheses, and we are going to try to find the 2 binomials that will multiply to give us this. Well, the first 2 terms have to multiply to give us x squared. So when we factor, the first 2 terms are going to be x and x. Then we come over here, the last 2 terms have to multiply to give us a positive 3. Well, the only choices of multiplying to give us a positive 3 are 1 and 3, either both positive or both negative. Well, then the last piece is they have to add to give us negative 4x. So if we put in a negative 1 and a negative 3, notice when we multiply this out, we're going to get first 2 terms of x squared. Outers would be negative 3x. Inners would be negative 1x. and then the last two would be plus 3, which would combine to give us back to our original problem of what we started with. Okay, let's do another one. This time we've got 3x squared plus 4x plus 1. Again, there is no greatest common factor. Nothing will divide into 3, 4, and 1. So we're going to set up our two sets of parentheses. First two terms have to multiply to give us 3x squared. Well, that means it's going to be 3x and x. The last two terms have to multiply to give us a positive 1. Well, the only numbers that are going to multiply to give us positive 1 are 1 and 1. Because it's a positive, they're both either positive or both negative. They have to add, the outers and the inners have to add to give us a positive 4x. Well, if the signs are both the same and they have to add to give us a positive 4x, that means we've got a plus 1 for each term. That way the outer two terms would give us 3x. The inner two terms give us 1x. So 1x and 3x gives us a middle term of 4x. So that is factored form. Factor 2x squared minus 4x minus 3. So the first two terms have to multiply to give us 2x squared. So we're going to choose 2x and x. The last two terms have to multiply to give us 3. Well, our choices are 1 and 3 or 3 and 1. Now in this case it's a negative 3, so we've got one positive and one negative. And then the outers and the inners have to combine to give us negative 4x. So let's just guess. If we do a 3 and a 1 this way, we get outer 2 is 2x, inner 2 is 3x, 2x and 3x. If one's a positive, one's a negative, is not going to give us 4x. Therefore, 3 and 1 don't work. Let's try 1 and 3. Outer 2 is 6x, inner 2 is 1x. 1x and 6x, if one's a positive, one's a negative, will not give us negative 4x. Therefore, this one is prime, okay, which is the expression that we use when we cannot factor the trinomial. Now this last one, I'm going to change that to x squared minus 8x minus 9. So in this case, we know the first two have to multiply to give us x squared, so we'll do x and x. The last two terms have to multiply to give us a negative 9. Well, to get a 9, it's either 1 and 9 or 3 and 3. Because it's a negative 9, we know there's one positive and one negative. So let's just pick one. Well, if we do 1 and 9, outer 2 would give us 9x, inner 2 gives us 1x. 9x and 1x, we're trying to get negative 8x. So if that's a negative 9 and a positive 1, then we can get to factored form. Okay, so for our steps for factoring, we said if there's a greatest common factor, we factor it out to the front. Then if it's a trinomial, 3 terms, we see if we can use the backwards FOIL method. If there are 2 terms, if it's a binomial, then we want to see if we can factor by the difference of squares. Now what the difference of squares says is if you have a binomial of the form something squared minus something squared, then it factors as x minus y times x plus y. So our first question on difference of squares is, are there 2 terms? Yes. Difference means, is there a minus in the middle? Yes. And are both of these terms a perfect square? Yes, this is x squared minus 3 squared. Therefore, we could factor that as x minus 3, x plus 3. Second one, 4x squared minus 25. Can we factor that by a difference of squares? Well, there's 2 terms, minus in the middle. The first term, 4x squared, is a perfect square of 2x, which gives us 2x squared. 25 is a perfect square of 5. So if we rewrote that as 2x squared minus 5 squared, then we could factor that as 2x minus 5 times 2x plus 5. Third example, x squared plus 36. Notice it is a binomial. There's two terms, but this is a plus in the middle. Therefore, we call that a sum of squares, and a sum of squares will not factor unless there's a greatest common factor, which in this case there's not. If the expression will not factor, then it is prime, and if we're solving equations that are prime, then we're going to have to choose a different method to solve the equation. Okay, the factoring method used to solve quadratic equations. Step 1, set the equation equal to 0. Step number 2, factor the expression completely. Step number 3, set each factor equal to 0. This is our zero factor property. And then we're going to solve each piece. Now you can check your solutions by substituting your answers back into the original equation. If it makes a true statement, then you are correct. So to solve this equation by factoring, notice number 1, it's already set equal to 0. Number 2, it's already factored. So step 3 says set each factor equal to 0. Well, this says if 3x plus 4 times x minus 5 is equal to 0, then either 3x plus 4 is equal to 0 or x minus 5 is equal to 0. Then step 4 says solve each piece. Well, the first piece we're going to subtract 4 from both sides, so we get 3x is equal to negative 4. Divide both sides by 3, so x is equal to negative 4/3. The second factor, x minus 5 equals 0, we're going to add 5 to both sides, and we get x is equal to 5. So our two solutions will be x equals negative 4/3 and x equals 5. Now when we check this, notice if you plug negative 4/3 into the first piece, we get 0 times anything, which is going to be 0. That one checks. If we plug in 5 into the second piece, we get 5 minus 5 is 0, so any number times 0 is 0. So in this case, both of our solutions check. Let's do another one. To solve this equation by factoring, step 1, set it equal to 0. Step 2, factor. Well, to factor, first step, is there a greatest common factor? No, there's not. Nothing will divide evenly into 2, 13, or 15. So to factor this, we're going to set up our two sets of parentheses. First two terms have to multiply to give us the 2x squared. The outers and inners have to combine to give us 13x. And the last two terms have to multiply to give us 15. So for the first two, we've got 2x and x. The last two terms have to multiply to give us 15. Well, our choices are 1 and 15, 3 and 5. Now, because it's a positive 15, we know they're either both positive or both negative. But because we're adding to get a positive 13x, that means both of our signs in factor form are going to be a plus. So let's just try one. Let's try 3 and 5. That would give us outer 2 is a 10x, inner 2 is 3x. 10x plus 3x gives us our middle term of 13x. So there's our factored form. Now we're going to set each factor equal to 0. Well, that means either 2x plus 3 is equal to 0 or x plus 5 is equal to 0. First case, subtract 3, so we get 2x equals negative 3. Divide by 2 and we get negative 3 over 2. Second case, subtract 5, so x is equal to negative 5. So there are our two solutions. Okay, solve by factoring again. X squared equals negative 6x minus 5. Now notice this one we do not have it set equal to 0. So the first thing we're going to do is we're going to add 6x to both sides. And we're going to add 5 to both sides. So we get x squared plus 6x plus 5 equals 0. Now we're going to factor it. Well, there's not a greatest common factor, so we're going to set it up to do like we have been doing. So we've got x and x. Last two have to multiply to give us a positive 5. Well, our only choice is positive 1 and positive 5. That checks, so our factored form is x plus 1 times x plus 5. Now we're going to set each of those factors equal to 0. X plus 1 is equal to 0. X plus 5 is equal to 0. First case, subtract 1, so we get x equals negative 1. Second case, subtract 5, and we get x is equal to negative 5. I promise all of these do not have a solution of negative 5. It looks that way, but really they don't. Next example, 4x squared equals 81. We're going to start out by setting it equal to 0. So we're going to subtract 81 from both sides. So we get 4x squared minus 81 equals 0. Now in this case, to factor, there's not a greatest common factor. Notice there's two terms, minus in the middle. The first term is a perfect square of 2x. Second term is a perfect square of 9. So that's going to factor 2x minus 9 times 2x plus 9 equals 0. Now when we set each of these equal to 0, we're going to get 2x minus 9 equals 0. 2x plus 9 equals 0. Get x is 9 over 2. The second case is going to be the same thing, except we're going to subtract 9 from both sides. It's going to be negative 9 over 2. So our solutions to this equation are 9 over 2 and negative 9 over 2. Okay, let's do another one. X squared plus 3x equals 0. Let's go back and review. Remember, this is quadratic because the highest power is a 2. To solve a quadratic, you set it equal to 0, which this one is. Factor it. Now this one has two terms, but we always start by GCF. Our greatest common factor for this problem would be x. So if you pull an x out of the first term, it would leave you with an x. If you pull an x out of 3x, it leaves you with 3. So there's our factored form. Now we're going to set each of these factors equal to 0, which means either x is 0 or x plus 3 is 0. Well, if x equals 0, there's our solution. The second case, we're going to subtract 3, and we get x is equal to negative 3. Notice that all these equations where the highest power is 2 have two solutions. That's typically the case. Okay, we'll find a few exceptions, but for the most part, if the highest power is 2, we're looking for two solutions. Okay, objective 2 is solving quadratic equations by the square root property. Now the square root property says if a squared is equal to b, then a is equal to plus or minus the square root of b. Okay, what that means is if x squared is equal to 9, well, remember, we know that something squared equals 9. We know 3 works because 3 squared is 9. Also, negative 3 works because negative 3 times negative 3 is positive 9. So what the square root property says is you can square root both sides. So the square root of x squared is x. You can square root the 9 and get 3, but you have to consider the positive and negative root of 9. Now, not all equations have real solutions. If it does not, just say no real solutions. Let's do an example of the square root property. It says solve x squared equals 16. Well, notice the square root property, we want one side to be something squared, and we want the other side to be a number. So what we can do is we can square root both sides. So when we square root the x squared, we just get x. When we square root the 16, we get 4. But remember, the square root property says we have to consider both cases, so x is equal to positive or negative 4. Let's do another one. X squared equals 64. Notice this is perfect for the square root property. Something squared, x squared, equals a number. So the square root property says we can square root both sides, but we have to consider the positive and negative root of 64. Well, the square root of x squared is just x. The square root of 64 is 8, but we've got to consider both cases, so we get positive 8 and negative 8. Now you can write them separately, or you can just continue to write it plus or minus 8. Now this one looks a little different. X squared minus 5 equals 0. Notice it's not of the form something squared equals a number. But if we added 5 to both sides, we get x squared is equal to 5. Now it's of the form something squared equals a number. So the square root property says we can square root both sides. We have to consider both cases on the right side. Well, the square root of x squared is just x. You can't take the square root of 5, so we're just going to call it the square root of 5. But we have to consider both cases. So our solution would be x equals positive square root of 5 and x equals negative square root of 5. Okay, solve this one by the square root property. Well, same thing. You want just the perfect square on the side by itself. So the first thing we're going to do is subtract 2. Divide both sides by 2. So we get x squared equals negative 1. Well, notice that nothing squared will give us negative 1. So in this case, we are going to say that there is no real solution. Now let's go back to factoring for a minute. We could have looked at this and said, well, this will factor. There's a greatest common factor of 2. So if you pull out a 2, you get 2 times x squared plus 1. If you set each of those equal to 0, you get 2 equals 0, x squared plus 1 equals 0. Well, 2 can't equal 0, so we throw that one out. X squared plus 1 equals 0. This will not factor because it's a sum of squares, therefore it's prime, so the equation does not have a solution. Okay, what about this one? X plus 4 squared equals 25. Well, this is of the form something squared equals a number. The square root property says to get rid of the square, we're going to square root. If we square root one side, we have to square root both sides, and then we have to consider the positive and negative root on one of the sides. Well, the square root of x plus 4 squared is just x plus 4. The square root of 25 is 5, but we have to consider the positive and negative of 5. Now, to get x by itself, we're going to subtract 4 from both sides. So we get x equals negative 4 plus or minus 5. Well, that's our two cases. The plus case is negative 4 plus 5, which is 1. The minus case would be negative 4 minus 5, which is negative 9. Let's check it. If we go back to the original problem and plug in 1, we get 1 plus 4 squared, which is 5 squared, which is 25. That one checks. Let's plug in negative 9. We'd get negative 9 plus 4 squared, which is negative 5 squared, which means negative 5 times negative 5, which is 25. So that just shows you that both solutions check. So we would write x is equal to 1 and negative 9. Another one. Solve by the square root property. Notice again, something squared equals a number. We're going to square root both sides, consider both cases. Well, when you square root the left side, that's going to cancel and give us 2x plus 1. The right side would just give us positive or negative square root of 13. Now, the square root of 13 will not simplify, so now our job is to solve for x. So we're going to go minus 1 on both sides, so we get 2x is equal to negative 1 plus or minus the square root of 13. Now to get x by itself, we've got to divide by 2, so x is equal to negative 1 plus or minus the square root of 13 over 2. Now sometimes when you write your answer in my math lab, you're going to have to enter it separately, so you would say negative 1 plus the square root of 13 over 2 and negative 1 minus the square root of 13 over 2. Objective 3. Solving quadratics using the quadratic formula. Now, we've talked two different ways so far. The factoring method works well if you know how to factor and if the equation will factor. The square root property is pretty short, but it only works if it's of the form something squared equals a number. Now, the quadratic formula will solve any quadratic equation in the form ax squared plus bx plus c equals 0. It's a little bit messy, but it works for every single quadratic equation. Now what the formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you will need to memorize this formula because you're going to use it a lot, and we're not going to give it to you on a quiz. Okay? So you've got to know the formula. You need to learn this quadratic formula. Now in the formula, you notice you've got a's, b's, and c's. Remember, a is the number in front of your x squared term. B is the number in front of the x term. And c is the number that's left over when you have the equation set equal to 0. So to solve this equation using the quadratic formula, we need to identify a, b, and c. Well, a is the number in front of the squared term. B is the number in front of the x term, but well, because it's a plus x, that means b is 1. And c is the number at the end, so c would be negative 7. So we would get our formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, which would give us negative b, which is basically the opposite of whatever b is, so negative 1 plus or minus b squared, so that would be 1 squared minus 4 times a, but a is 4, times c, c is negative 7, divided by 2 times a, and again a is 4. So we get negative 1 plus or minus the square root of, well, 1 squared is 1. Now this is a tricky part. You've got a minus and you've got a negative. Well, minus a negative is going to give you a plus. Now we've got 4 times 4 is 16. 16 times 7 is 112. Divided by 8, which would give us negative 1 plus or minus the square root of 13 divided by 8. Not a nice pretty answer, but that's our solution. Now objective 4 is on the discriminant. Now the discriminant is the part of the quadratic formula that's under the square root sign. So if our formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, then just this part in here, that is the discriminant. So think about this for a minute. Let's say we had a number negative 2 plus or minus the square root of 25 divided by 4. If this discriminant is a perfect square, then we can take the square root of that perfect square, get a number, which would be negative 2 plus or minus 5 divided by 4. Notice we're just going to get two regular numbers. Okay, that's what we're going to say, two rational solutions. If we went through and did it, let's say we calculated our discriminant and we got a negative number. Well, when we tried to simplify that, the square root of a negative number, that's not a real number. This one can't be done if we're only talking real solutions. Okay? Our next one would be, what if we had negative 2 plus or minus the square root of 0 over 4? Well, the square root of 0 is 0. So in that case, we're just going to get negative 2 over 4. Now notice in this case, we're going to have one rational solution. Okay, then the other alternative would be, what if it's negative 2 plus or minus a number that's not a perfect square? Well, square root of 10 will not simplify. We're still going to have two answers because one's a plus and one's a minus. But the only difference between this one and the first case is we're going to have two irrational solutions, or two solutions that contain square roots. Okay, so we're going to use the discriminant to determine the number of and types of solutions to a quadratic equation. Okay, like we said earlier, if b squared minus 4ac is a positive number that is a perfect square, then there are going to be two real rational solutions. That was the example I gave you, negative 2 plus or minus the square root of 25 over 4. Square root of 25 simplifies to 5, and we're able to find our two answers. If b squared minus 4ac is positive, but it's not a perfect square, okay, that was our negative 2 plus or minus the square root of 10. Okay, we still get two answers. They are just going to be two real irrational solutions. And if b squared minus 4ac equals 0, well, that was the negative 2 plus or minus the square root of 0. We said the square root of 0 is 0, so that cancels out, and we just end up with one rational solution. And then the last case was, if that discriminant, b squared minus 4ac, is less than 0, therefore if it is a negative number, well, you can't take the square root of a negative number, therefore you cannot have a solution. Okay, now, how does this discriminant compare when we look at the graph? Well, if b squared minus 4ac is greater than 0, which means it is a positive number, then we're going to have two real solutions. Now, they can either both be rational or they can both be irrational. If our parabola opens upward, then we're going to have the two numbers cross the x-axis. Same thing if it opens downward. We're still going to have where our parabola crosses the x-axis, and that's going to be our solutions. If the b squared minus 4ac is 0, then what the graph looks like is it touches the x-axis in one place. So for this one, it could touch it down here at 4, or it could touch it back here at negative 5. But the point is, it only touches the x-axis in one place. Therefore, there is only one rational solution. And then our last case is if b squared minus 4ac is less than 0. Therefore, if your discriminant is negative, there are no real solutions and no x-intercepts. We could have our parabola up in the upper quadrants aiming upward, or in the lower quadrants aiming downward. Okay, let's do an example. Find the number of and types of solutions. We don't want you to solve yet, just talk about the solutions. Anytime we want to identify our solutions, we're going to say d equals b squared minus 4ac, because that's the part that's under the square root sign. So for our example, a is negative 3, b is negative 6, and c is 15. So when we plug this in, we're going to get negative 6 squared minus 4 times negative 3 times 15, which would give us 36. Again, you've got minus here, negative here, which is going to be plus a positive. 12 times 15 is 180. So when we add 36 and 180, we're going to get 216. Well, is 216 a perfect square? No. So this is positive, not a perfect square. So we are going to have two real solutions. Or if we want to go one step further, we can say two irrational solutions because we're not able to totally simplify the square root. Let's do another one. Now, in order to use the discriminant for this one, we need to set it equal to 0, so we're going to subtract 2x from both sides. We're going to put it in descending order so that we get x squared minus 2x minus 5 equals 0. Well, let's identify our a, b, and c. A is 1, b is negative 2, and c is negative 5. Well, our discriminant, which is b squared minus 4ac, would give us negative 2 squared minus 4 times 1 times negative 5. So we get a discriminant value of 24. Now 24 is greater than 0. It's not a perfect square. So what we're going to have is two real irrational solutions. Okay, one more of these. Find the number of and types of solutions. So for this problem, when we set it up into our discriminant formula, we've got b squared minus 4ac, which is 29 squared minus 4 times 7, which would give us 29 squared minus 4 times 7, which gives us 729. Well, is 729 a perfect square? Let's check. So we're going to go second square root of 729, and that gives us 27. So this is a positive number that is a perfect square. Therefore, we are going to look for two real rational solutions.